between the given line and normal to the given plane. So now here cos theta, theta is nothing but here pi by 2 minus theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square and a2 square plus b2 square plus c2 square. So now cos 90 minus theta is nothing but sin theta. Sin theta is equal to the same a1 a2 plus b1 b2 plus c1 c2 by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. So remember this one, what is the sign? This one theta equal to sine inverse of this one. So what is theta here? Theta is equal to sine inverse of this one is nothing but the angle between a line and a plane. Now we go to take example under this kind of problem. Find the angle between the line and the plane, this one. So what is the given line? X minus 1 by 2 is equal to y plus 1 by minus 1 is equal to z minus 3 by 4. And what is the given plane? X plus 2y plus z is equal to 12. So now we know that the angle between a line and the plane. So what is the angle between the line and the plane? That is theta. So then we can find the angle between the line and the normal to the plane is pi 90 minus theta. So what is the difference to both lines? Theta is the angle between line and the given plane, this line and this plane. But we have to find the angle. To find angle between the line and the plane, we have to find the angle between the line and the normal to the plane. That angle is nothing but 90 minus theta. Now apply the formula here. Before go to apply the formula, first we have to choose what are the direction ratios of the given line and what are the direction ratios of the normal to the given plane. So from the line, what are the direction ratios? 2, -1, 4. And from the plane, the direction ratios are 1, 2, and 1. So A1 is A1, B1, C1. A1 is 2, B1 is -1, C1 equal to 4. From here, A2 is 1, B2 is 2, C2 is 1. Now apply the formula and substitute A1, A2, B, A1, A2, B1, B2, C1, C2 values. So therefore, our required angle is cos 90 minus theta is equal to A1, 2 into A2, 1 plus B1, B2 minus 1 into 2, this one, plus C1, C2, that is 4 into 1 divided by, so square root of A1 square, 2 square plus B1 square minus 1 square plus C1 square, that is 4 square into square root of A2 square, 1 square plus B2 square, 2 square plus C2 square means 1 square. Now simplify this one. What is the cos 90 minus theta? Sin theta. This is equal to 2 into 1, 2, and minus 1 into 2, minus 2, plus 4 into 1, 4, divided by square root of 2 square is 4 plus minus 1 whole square means 1 plus 4 square is 16 into square root of this one, 1 plus 4 plus 1. This is equal to, so 2 minus 2 gets cancelled, 4 is remaining part, 4 by square root of 21 into square root of 6. So we can write this one into 7 into 3, that is root 3 into root 7. So root 6 can be written as root 3 into root 2, that is root 6. So root 3 into root 3 gives, that is 3. So 3 into root of 7, root 7 into root 2 is square root of 14. So 4 by 3 into square root of 14 is sin theta value. And then theta is sin inverse 4 by 3 into square root of 14. So this is the angle between the given line and the given plane. Now we go to discuss about a point of intersection of the line with the plane. So this is the given line. For example, here we consider the equations of the straight line in symmetric form. So what is the symmetric form? X minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N is equal to R. So this is in symmetric form, equations of the straight line in symmetric form, what we have discussed in earlier class. Now we go to take the plane. So ax plus by plus cz plus d equal to 0 is the plane, the equation of the plane. So now we are going to find the point of intersection of the line with this plane. So now what is the problem here? Finding the point of intersection of this line with this plane. So now we know that from this from this straight line, any point on this line is, we already we have discussed this one. So any point on this line is nothing but the first term is equal to R. That means x minus x1 equal to LR. That means x is equal to x1 plus LR. So the first one point is x1 plus LR. X equal to x1 plus LR, that is x coordinate. From the second one, y minus y1 by M is equal to R. So from this one, y minus y1 equal to MR, and we will get y equal to y1 plus MR. So that y coordinate is y1 plus MR. Now we go to find z coordinate. So similarly, we can get z minus z1 equal to NR and z equal to z1 plus NR. This one, z coordinate. So this is x coordinate, this is y coordinate, this is z coordinate. So this is any point on the given line one, this one. Now, this if this point lies on this plane, lies on the given plane, so then definitely this point satisfies this equation. So that means satisfies means take this x coordinate in the place of x, take y coordinate value in the place of y, and take z coordinate in the place of z in this equation. So that means if this point lies on the plane 2, then that means A into what is x coordinate? X1 plus LR plus B into y coordinate, Y1 plus MR plus C into what is Z coordinate? This one, Z1 plus NR plus D as it is equal to 0. Now simplify this one. So now AX1 plus by1 plus cz1 plus d is can be written as one term, plus take common r from these two, from this one and from this one and from this one, from these three terms, and then r into ALR plus M BMR. What is this? BM plus CNR. That means CN. We take common R from these three terms, this one and this one and this one, we get this one, R into AL plus BM plus CN equal to 0. Now, so first term plus R into second term equal to 0. Therefore, R equal to minus of AX1 plus BY1 plus CZ1 plus D by AL plus BM plus CN. Now, substituting the value of R, this is the value of R in the point 3. What is the point? The point which is lie on the equation, given straight line. So now substitute R value in this one. So we get the x coordinate value, y coordinate value, and z coordinate value. Observe here, what is x1 value? Constant. L is constant. So R value, this one, R is constant value. So anyway, A, B, C, D are constants, L, M, N are constants, X1, Y1, Z1 are also constant values. Anyway, R gives constant value. So everything value is constant. And here we get constant value and constant value by substituting R value. So then after substituting R value in this point, we get the point of intersection of the given line with the plane. So this is the point of intersection of the given line, this one with the given plane, when substituting the R value, this value. So now we go to take example under this problem. So find the coordinates of the point of intersection of the line x minus 1 by 2 is equal to y minus 3 by minus 1 is equal to z minus 4 by 1 with the plane 2x minus 2y plus z plus 3 equal to 0. Here, what is the given equation? This one. This is the given equation. So this is in symmetric form. So definitely it is equal to R. So now, what is R? This means the first term is equal to R. We get x coordinate as 2R plus 1. And this one equal to R. Then y equal to minus R plus 3. And this one equal to R. We can get z coordinate, that is R plus 4. So the x, y, z coordinates are this one, and write as a point 2r plus 1 comma minus r plus 3 comma r plus 4. So x coordinate value, y coordinate value, z coordinate value. So these are the coordinates of the point on the line, given line, any point. Now, if this point lies on the given plane, then we have, obviously we know that definitely this point satisfies the given plane. So then we can get what is the given plane? 2x minus y plus z plus 3 equal to 0. Now take x value this one, y value as this one, z value as this one in the plane. 2 into x, 2r plus 1 minus y. What is y? Minus r plus 3 plus z. What is z? r plus 4 plus 3 is equal to 0. Now simplify this. After simplifying this one, we will get 4r plus 2 minus minus plus r minus plus minus 3 plus r plus 4 plus 3 is equal to 0. Now, which implies that 6r plus 6 is equal to 0, and then 6r can be written as minus r is equal to minus 1. The value of r is here minus 1. Now, if we can take r value in the point, this one, then we get the required point of intersection of the given line with the given plane. So what is r value? Minus 1. Take minus 1 in this one. 2 into minus 1, minus 2 plus 1, and minus of minus 1, plus 1 plus 3, and minus 1 plus 4, like this. So minus 2 plus 1 is minus 1, 1 plus 3 is 4, minus 1 plus 4 is 3. Minus 1 comma 4 comma 3 is the point of intersection of the given line with the given plane. This is the condition how to find the point of intersection of the given line with the given plane. Now we go for another concept, that is conditions for a line to lie in a plane. So now what are the conditions for a line to lie in a plane means, suppose we consider x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N is the equations of the straight line. And also we take ax plus by plus cz plus d equals 0 is the equation of the plane. So then the necessary and sufficient conditions for a line, given line 1, to lie in a given plane 2 are these two. What are the conditions? AL plus BM plus CN equal to 0, AX1 plus BY1 plus CZ1 plus D equal to 0. So if you observe this one, L, M, N are these are, okay, direction cosine, these L, M, N. And A, B, C are coefficients of x, y, z respectively in the plane. And x1, y1, z1 is the point. What is the point? This line passes through the point x1, y1, z1. So that is the point. So these two are conditions. The necessary and sufficient conditions for a line to lie in a plane are these two. Now we are going to see the proof of this one. Any point on the line 1 is, what is the line here? This one. Any point on this line means this is in symmetrical form. This is equal to R. As we have explained earlier, x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N is equal to R. So after that, this one equal to r, and second one is equal to r, and third one is equal to r. From the first one, we get x1, x is equal to lr plus x1, and m equal to y equal to mr plus y1, and z equal to nr plus z1. So this is any point on the given line 1. And now give equation number 3. Now, first we have to give the equation number 1 and equation number 2, and then give equation number, this is the 3, because this is any point on the given line 1. If this line has to lie in plane 2. So this line, what is the line? The given line lies in the plane. Then definitely any point on this line uh, also lies in the plane ax plus by plus cz plus d equal to 0. And according to this condition, so this is any point on the given line, so that definitely this line lies on this plane. So if this point lies on this plane, that means this point satisfies this plane. So that means take xyz values in place of xyz in the plane respectively from this point. Now ax lr plus x1 plus b into y, what is y, mr plus y1 plus c into z nr plus z1 plus d equal to 0. Now, the first one is ax1 plus by1 plus cz1 plus d. Take one term. And now lr. So, take common r from this term and from this term and from this term. And then you get r into al plus from this one r into bm plus r into cn from this one. So r into al plus bm plus cn plus another term is ax1 plus by1 plus cz1 plus d equal to 0. After simplifying this, we will get this one. So now if you observe this one, r is our, what is r? So in the case of equations of the straight line in symmetric form, r is the distance from the point a to the point p, where P is the point on the line AB in the plane. So that R, this equation holds for all values of R. So this equation holds for all values of R. Then the coefficient of R, what is the coefficient of R? This one, AL plus BM plus CN should vanish, and also this constant term also should vanish. So therefore, AL plus BM plus CN equal to 0, and then ax1 plus by1 plus cz1 plus d is equal to 0. So now our necessary condition, this is the necessary condition. So what is this? We take the given line and given plane, then we can get these two, or these two equations as the conditions. So what are these? These two are the conditions for the line to lie in the plane. Now we go to see converse result. What is the converse result? Take these two equations and then find the required line. So what are these two equations? So anyway, AL plus BM plus CN equal 0, one equation. Other one is AX1 plus BY1 plus CZ1 plus D equal to 0. So from these two equations, what is this? What is this? This equation. So from our throughout previous discussion, we can say that this equation shows that the line 1, what is the line is perpendicular to the line is perpendicular to the normal to the plane. So that means L, M, N are direction ratios, and A, B, C are direction ratios of the plane, L, M, N are direction ratios of the line. Then we can write AL plus BM plus CN equal to 0. So we have seen this condition in previous classes. So that means it shows that the line is perpendicular to the plane. What is line? That line which is having direction ratios as LMN, and ABC are the direction ratios of the plane AX plus BY plus CZ plus D equal to 0. So one condition is satisfied. The other condition is ax1 plus by1 plus cz1 plus t equals 0. What is this condition? So the line passes through the point x1, y1, z1, the point x1, y1, z1 in the plane ax plus by plus cz plus d equals 0. This equation shows that the line, what is the line? Straight line passing through the point x1, y1 and z1 in the plane ax plus by plus cz plus d equal to 0. So anyway, from these two equations shows that the line, what the line is this one and the plane is this one. Okay, from these two equations we can get this line and this plane. So then converse result is also holds. So anyway, these two conditions are conditions of the line to lie in the plane. Now we go to see the another condition, that the conditions for a line to be parallel to the plane are AL plus BM plus CN equal to 0, and then AX1 plus BY1 plus CZ1 plus D is not equal to 0. And if this condition satisfies, then this is the condition for a line, given line to be parallel to the given plane. And next we go to see another condition, that is the condition for a line, given line to be perpendicular to the given plane is L by A is equal to M by B is equal to N by C. So here ABC are direction ratios of the normal to the given plane. LMN are direction ratios of the normal straight line, direction ratios of the given straight line. So x1, y1, z1 is the point. So the line passing through the point x1, y1, z1. So anyway, these are the conditions for a line to lie in a plane. Now we go to see another result. We know that the equation of any plane containing the line ax plus by plus cz plus d equal to 0 and a1x plus b1y plus c1z plus d1 equal to 0 is ax, first one, ax plus by plus cz plus d plus lambda into second one, a1x plus b1y plus c1z plus d1 equal 0, where lambda is a parameter. For example, when the equations of the line are in general form. So what is this one? This is the equation of the plane. And this is another equation of the plane. So those are non-parallel planes. So if you take these two planes together, we can say that these two planes are equations of the straight line in general form or in unsymmetric form. So the straight line lies on these two planes. Okay, so that is why this is, now we can find the when the given straight line is in this form, then we can find the equation of any plane containing this line is like this. Similarly, if the equation of the straight line gives in symmetric form like this, the equations of the line in symmetric form is like this. When the equation of the straight line in this form is given, we can find the equation of any plane containing this line is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0, such that AL plus BM plus CN equal to 0. So this condition satisfy అయ్యే విధంగా ఇది plane equation అవుతుంది when the equation of the straight line is given in symmetric form. Remember these 2 points. So these are useful in further studies. Now we go to find the coplanar lines and condition for the coplanarity of lines. So what are the coplanar lines? Suppose there are two given lines, like for example these two are two given lines, and suppose that these two are intersecting lines. If these two intersecting lines lie on the same plane, then these two equations of the straight line, these two lines are said to be coplanar lines. Here, what is our problem here? We find the condition that two given planes, two given lines are coplanar. So now here we are going to find the condition that these two given lines are coplanar. Okay, so that means coplanar means definitely these two lines should lie in a same plane. Now, what is the condition? Let us see that the equation of any plane containing the line 1 is this one. So just now we have seen the result. The equation of any plane containing this line is a into x minus. What is ABC? A into A plane. ABC are direction ratios of the given plane. Direction ratios of the normal to the given plane. So x minus x1 is from the given line this part. Y minus y1 is this one and z minus z1 is this one. So now L, M, N are these are from the line L, M, N are these. Now apply this formula here. What is that? Equation of any plane containing the line 1 is this one. A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal 0 with the condition is AL1 plus BM1 plus c into this n1 equal to 0. So give equation number 1 and 2. For these two, give equation number 3 and 4. Now, anyway, this is the equation of the plane containing the line 1. So, this is the equation of the plane according to the line 1. And now, if this plane contains the line 2, if this is the plane, if this plane contains the line 2, then we have the point x2, y2, z2 on line 2 is also the point on the plane on this plane. Okay, if this plane containing the line 2 means the first point is the point x2, y2, z2 on the line on this line also lies on this plane, also lies on this plane. So that means x2, y2, z2 is the point which lies on this plane means that point satisfies this equation. Satisfies means take x2, y2, z2 in place of x, y, z respectively in this equation. Then we get a into x2 minus x1 plus b into here y2 minus y1 this is plus c into here take z2 in place of z2 minus z1 equal to 0. Now we take another condition is the line 2 is perpendicular to the normal to the plane 3. Okay. The next condition is the line 2 is perpendicular to the normal to this plane. So that means what is the condition? The direction ratios of the line L1, L2, M2, N2 and the direction ratios of the plane ABC. So then if we have these two direction ratios, we can have A into L2 plus B into M2 plus C into N2 equal to 0. So when the line 2 is perpendicular to the normal to the plane 3, we get this one AL2 plus BM2 plus CN2 equal to 0. So now from the first point, we get this one, give equation number 5. From the second point, we get this equation, give this equation as 6. Now we go to find the equation, solve the equations. Which equations? 4, 5, 6. So what is the equation for? This is the fourth equation in terms of ABC and fifth equation is in terms of ABC and sixth is also in terms of ABC. So we can eliminate ABC from these three equations 4, 5 and 6. We get the determinant form like this. The coefficients of ABC respectively. Take the coefficients of ABC from each equation. So from this equation, the coefficients of ABC are L2, M2, N2. Take L2, M2, N2, third row as third. And now if we go to the fourth equation number 4, so the coefficients of ABC are L1, M1, N1. So take L1, M1, N1 as second row. And next, take the coefficients of ABC from this equation. So what are these? X2 minus x1, y2 minus y1, z2 minus z1. Take like this. Sorry, this one. So now the coefficients of ABC from this equation are this one. Take these as the first row. So now they find the determinant of this one. Then we get some value. Now if it is this value is 0, so if this value is 0, then we go to say this is our required condition for given two lines to intersect. Okay, this is the condition for given lines to intersect it, given two lines. Okay, now if it is, so these two lines are intersect means definitely these two lines are said to be coplanar. Now, what is this determinant form? This one, x2 minus x1, y2 minus y1, z2 minus z1. Second row is L1, M1, N1. Third row is L2, M2, N2 is equal to 0. This one. Now, so in the first row, the first one element is x2 minus x1. Similarly, we can take x1 minus x2 also. From this one, y1 minus y2 also we can take. From this one, z1 minus z2 also we can take. If we take like that, so the second row is same and the third row is same, we can take. Now the value of this one is same as the value of this one, so that we can take like this also. So anyway, both are the any one we can take. So anyway, this is the condition for the lines to intersect. So if this condition also satisfied, if the lines are parallel, when the lines are parallel, this condition is also satisfied. We can say like that. Now, anyway, now we obtained the condition for a line, for the given lines to intersect. Now we are going to concentrate on finding the equation of the plane containing both the given equations. For that, we will do the work. So that is 3-4 equations. So now first let us see what are the 3-4 equations. What is the three equation? This one. A into x minus x1 plus b into y minus y1 plus c into z minus z1. Next, 5-6 equations. So what are 5-6 equations? This one, a into x2 minus x1 plus b into y2 minus y1 plus c into z2 minus z1 equals 0. And sixth equation is al2 plus bm2 plus cn2 equals 0. So from these three equations, so what are these three equations? 3, 4, 6. And then we can eliminate ABC. So after eliminating ABC from these three equations, 3, 4, 6, we can write like this. So the determinant of, so x minus x1, y minus y1, z minus z1. So from third equation, we can get the first row. So what is the third equation? We can get the first row. X minus x1, coefficient of A. And the coefficient of B is y minus y1. Coefficient of C is z minus z1. And the next, equation number 4. So what is equation number 4? This one. AL1 plus BM1 plus CN1 equals 0. So L1 is A coefficient, B coefficient is M1, C coefficient is N1. And take L1, M1, N1 as second row. And similarly, what is the sixth equation? AL2 plus BM2 plus CN2 equals 0. L2, M2, N2 are coefficients of ABC respectively. So take these three as third row. So then find the value, determinant value, this one, and is equal, if it is equal to 0, so then if you take the determinant value of this one is equal to 0, then it represents as the equation of the plane containing two given lines. So this is the equation of the plane containing two given lines. So now whenever you are going to find the equation of the plane containing to both the given equations, we can apply this formula. So this formula, same, this one, this is also known as the equation of the plane which passes through the first line. First line means these are they related to first line, which passes through the first line and parallel to the second line and parallel to the second line. So this is represent as the equation of, it represents as the equation of the plane which passes through the first line and parallel to the second line. And similarly, if we can take this one from the second given equation, from the second given line, we can take x minus x2, y minus y2, z minus z2. What is the second line here? Second given line. So this is the second given line. Take this x minus x2, y minus y2, z minus z2 as the first row. And this one L2, M2, N2, take one of the second or third, and L1, M1, N1 are taken as the one of the rows as second or third. This one. So from the second equation, if we take these three as first row and L1, M1 are second row and L2, M2, N2 as third row, and find the determinant value equal to 0. It represents the equation of the plane which passes through the second line and parallel to the first line. So what is the difference here? If you take the first row from the first line, then it represents as the equation of the plane passes through the first line and parallel to the second line. If you take the first row values elements from the second line, then it represents as the equation of the plane which passes through the second line and parallel to the first line. And you can apply these formulas to find the equation of the plane. So under this concept, I will give example here. Show that the lines, this one and this one, are coplanar and find the equation of the plane containing them. So now what is the procedure here? See the procedure. First observe the first line. What is the first line? X plus 3 by 2 is equal to y plus 5 by 3 is equal to z minus 7 by minus 3. Similarly, the second line is x plus 1 by 4 is equal to y plus 1 by 5 is equal to z plus 1 by minus 1. So from these two equations, so first we have to show that these two are coplanar. So what is the condition for the coplanarity of two given lines? That is, you can use any line. So take the first line. So what is the condition for the coplanarity of two given lines? X2 minus x1, y2 minus y1, z2 minus z1. Let me show that formula. This one. X2 minus x1, y2 minus y1, z2 minus z1. The first line direction ratio L1, M1, N1. The second direction ratios L2, M2, N2 equal to 0. And then or also we can take x1 minus x2, y1 minus y2, z minus z2. These two are same. Two rows are same. So any formula you can use. For to show the two given lines are coplanar, we have to use that formula. So from the first line, the point is minus 3, minus 5, and 7. From the second one, the point is minus 1, minus 1, minus 1. So what is x1? Minus 3. What is y1? Minus 3. x1. What is x2? Minus 1. So a minus 3 minus of minus 1 is minus 3 plus 1. So y1, y2. What is y1? Minus 5. So y2 is minus 5 plus 1. So y2 equal to minus 5 plus 1. So y2 equal to minus 5 plus 1. So y1 equal to minus 5 plus 1. So y2 equal to minus 5 plus 1. So y1 equal to minus 5 plus 1. So y2 equal to minus 5 plus 1. So y1 equal to minus 5 plus 1. So y2 equal to minus 5 plus 1. So y1 equal to minus 5 plus 1. So y2 equal to minus 5 plus 1.
గురుకులం పాఠశాల కంటే అప్లై 14 దాకా